This video looks at an example of what's called the factor theorem. We're told we have some polynomial which is cubic, which has got 3 roots at these 3 values. Now, if we know the roots, we can actually just write down the factors. Now, those two are probably easier. If 5 is a root, then x minus 5 is a factor. If minus 2 is a root, then x plus 2 is a factor. But if x equals minus half is a root, then the bracket which solves to give x equals minus half as a root will be 2x plus 1, because that solves to give x equal to minus a half. So they're my 3 factors. So I can therefore expand this to get it into the form as required. So if I expand the first 2 brackets first, I get x squared minus 5x plus 2x minus 3x. Minus 5 times 2 is minus 10. Then times that by 2x plus 1. If I then expand that out properly, I times through by 2x and then by 1, I get 2x cubed minus 6x squared minus 20x plus x squared minus 3x minus 10. So that expands to 2x cubed minus 5x squared minus 23x minus 10. So therefore I've written y in the form 2x cubed, a is minus 5, b is minus 23, c is minus 10. I can then sketch the graph quite easily, because I know where the roots are. So if I just quickly draw a pair of axes, then the roots are at 5, minus a half, and minus 2. It's only a sketch, not a scale. The y-intercept is at minus 10. That plus c, as we call it, is where the graph cuts through the y-axis. So therefore the graph only cuts through at these values and also cuts through at minus 10. So the graph must come up, then down, back up again. So we get this lovely smooth graph through those coordinates. So y equals x minus 5, x plus 2, 2x plus 1.